This is the OCR GCSE 9-1 Maths Paper 2 from the Foundation Tiers, and it's from the November 2019 series, and it's a non-calculator paper. Question 1 for part A, we have to work out 89 plus 14. So if we align everything vertically, we have 89 being added to 14. What you can see here is if we add those together, 9 plus 4, that's 13. So then we carry the 1 here. And then we've got 1 plus 8, which is 9, plus another 1, that's 10. So we've got a 0 here, and we carry the 1. And then we've got a 1 over here. And therefore, 89 plus 14, that's 103. And now for part B, we have to work out 17 times by 21. Well, one way we can do this is to use the grid method. We can split the 17 up as 10 plus 7, and then we can split the 21 up as 20 plus 1. 10 times by 20, that's 200. 10 times by 1, that's 10. 20 times by 7, that's 140. 7 times by 1, that's 7. And therefore, adding all these together, we have 200 plus 140 plus 10 plus 7. Adding these together, here we end up with a 7, here we end up with a 5, and here we end up with a 3. And therefore, 17 times by 21 is 357. Question number 2. The table shows some temperatures in degrees C. We've got Monday, Tuesday, Wednesday, Thursday and Friday and their associated temperatures. For part A, we have to find the difference between the temperatures on Thursday and Friday. Well, the difference will equal 6 take away negative 3. Minus and a minus gives us plus. So here we have 6 plus 3, which is 9. So the difference is 9 degrees C. Now for part B, on Saturday the temperature was 7 degrees higher than on Friday. We have to find the temperature on Saturday. Well, the temperature on Friday is equal to minus 3. That's what we know so far. And if we have 7 degrees higher, adding on 7 to negative 3, we get 4. And therefore the temperature on Saturday was 4 degrees C. Question number 3, we have to complete each statement by writing the missing value in the box. Well, we've got 2/5 being equal to 4 over something. You can see to go from the 2 to the 4, we have to multiply by 2, and therefore 5 times by 2, that's equal to 10. So 4/10 is equal to 2/5. And now for part B, we've got 2 1/3 equals something over 3. Well, here we have to write our mixed number as a top heavy. And to do that, we'd have 2 times by 3 plus 1 divided by 3. So we've got 6 plus 1, which is 7. So we've got 7 over 3 being equal to 2 1/3. So here we have 7/3. And now for part C, we've got 7 times 7 times 7 times 7 times 7 equals 7 to the something. Well, 7 is being multiplied by itself 5 times, and therefore we've got 7 to the power of 5. Question number 4 for part A, we have to work out 5/6 of 18 kilograms. Well, 1/6 of 18 kilograms, this is equal to 3 kilograms, and therefore for 5/6 of 18 kilograms, we would have 3 times by 5, which is 15. So we've got 15 kilograms. And now for part B, we have to work out the difference between 5 pounds and 1 pound 49. Well, over here, currently if I draw a number line, we're at 1 49 and we want to get to 5. Well, if I add on 0.51, what we will end up with is 2. And to go from 2 to the 5, we'd have to add on 3. And therefore, what we have here is a total of £3.51. And now for part C, we have to work out 0.15 divided by 5. Well, if we had 15 divided by 5, this will equal 3. But the 0.15 is 100 times smaller than the 15. And therefore, 0.15 divided by 5, this will equal 3 divided by 100, which is 0.03. So we have 0.03. Question number 5, we have to write 0.3 as a fraction. Well, here we've got one digit after the decimal point, so our fraction will be out of 10, and therefore we'd have 3 out of 10. And now for part B, we have to write 1/4 as a decimal. Quite simply, this is 0.25. Question number 6, we have to write the following in order of size, with the smallest first. Well, you can see here we've got a number given to 1 decimal place. Here we've got to 2 decimal places, 3 decimal places, 3 decimal places, and 2 decimal places. Well, the greatest number of decimal places we have is 3. So it would make sense for us to write everything to 3 decimal places. So 0.61 is the same as 0.610. 5.9 is the same as 5.900. And the 5.98 is the same as 5.980, as we see here. And now it becomes easier to compare the numbers. Well, the smallest will be this here. And then if we compare the others, well, here the first decimal place is 9, here the first decimal place is 9, and so the first decimal place here is also 9. So the next smallest one is this, because the next decimal place starts with 0. And then if we compare the other ones, well, the first decimal place starts with 9. We'll ignore that for a second, but if we look at the second decimal place, this starts with 0, this starts with a 7, and this starts with an 8. So the next smallest one is this. And then here this one starts with a 7 for the second decimal place, and this one starts with an 8. So this one is the next smallest, followed by this. So when we come to write down the numbers in order of size, with the smallest first, well, we've got the 0.61 being the smallest, followed by the 5.09, followed by the 5.9, followed by the 5.9, followed by the 5.977, followed by the 5.98. Here are the numbers in order of size. Question number 7, we have to work out the following, giving each answer as a fraction. Well, first of all, we've got 1 3/4 plus a half. What we need to do first of all is convert the 1 3/4 to a mixed number. So, if we do that, what we would have here is 1 times by the 4 plus the 3 divided by 4, and then we're adding on 1/2. So we have over here, if we tidy this up even further, 4 plus 3, that's 7. So we've got 7/4 plus 1/2. And there are various different ways of doing this. One way is to write everything over a common denominator. We have 7/4 plus, well, 1/2 we can rewrite that as, if we want a denominator of 4, we can rewrite a half as 2 over 4. And therefore you can see we will end up with 9 over 4. So we have here 9 over 4, which if you want to write that as a mixed number, well, 4 goes into 9 2 whole times, and what's left over is a quarter. So we have 2 and 1/4. And then for part B, we have 3/8 divided by 2. Well, this here is equal to 3 over 8 times by 1 over 2. So we've got 3 times by 1, which is 3. 8 times by 2, that's 16. And therefore we have 3 over 16. And now for part C, we've got a third times by a half. Well, 1 times by 1, that's just 1. 3 times by 2, that's 6. So we've got 1 over 6. Question number 8. Hannah saves an amount of money each week. Here are the amounts in pounds that she saved in the first 5 weeks of 2019. We've got 13, 58, 11, 22 and 11. For the first part of part A, we have to find the median of the 5 amounts. Well, what we can do here is write all the numbers in order. So we've got 11, 11, 13, 22 and 58 for the numbers written in order, with the smallest number over here. And therefore for the median here is equal to 13. And then for the range is equal to the largest amount, which is 58, take away the smallest, which is 11. 58 take away 11, you'd find that to equal 47. So the range is 47. And now for part B, in the 6th week, she also saved some money. The mean amount that Hannah saved each week over the 6 weeks was £22. How much did she save in the 6th week? Well, first of all, the mean, that's given by the sum of all the numbers divided by n, and therefore the sum of all the numbers is equal to the mean times by n, the number of numbers we have. So therefore we can work out the sum of all our numbers. We have n here is the number of pieces of data. So we've got the mean, which is 22 times by 6, because we've got 6 pieces of data. So 22 times by 6, well, 2 times by 6 is 12, so 20 times by 6 is 120. 120 plus 12, that's 132. So the sum of all the pieces of data is equal to 132. So now what we can do is find out how much should have in the 6th week. So therefore in the 6th week we've got 132, take away, well, we've got the other pieces of data, 11, 11, 13, 22 and 58. So if we work all of this out, it turns out we would get 17. So therefore, in the 6th week, she saved £17. Question number 9. The scale drawing shows the position of 2 boats, P and Q, and we've got a scale 1 centimetre represents 4 kilometres. And for part A of the question, we have to find the actual distance between the boat P and the boat Q. Well, all we have to do here is measure the distance from P to Q. You will find that to be 5.2 centimetres. So here we've got 5.2 centimetres, and if we times this by 4, well, 5 times by 4, that's 20, 0.2 times by 4, that's 0.8, So we've got 5.2 times by, we've got 20.8 kilometers. So we've got 20.8 kilometers. And now for part B, we have to measure the bearing of boat Q from boat P. So we're going from P to Q, and if we grab our compass, if we grab our protractor, and what we'll do as well is we'll draw a line from here to here, and then if we measure that angle, aligning the 0 with the north line, what you'd find here, we get an angle of, well, here's 65, we've got an angle of 67. So the bearing is 067. Remember, we need 3 figures for a bearing. And then for part C of the question, a lighthouse is 18 kilometers from boat P, and on a bearing of 200 degrees from boat Q. On the scale drawing, you have to mark a possible position of the lighthouse with a cross. Well, if we divide 18 by 4, then 18 divided by 4 is 4.5. So what we would have here for the 18 kilometers, that's 4.5 centimeters, and 200 degrees from Q, what we'd have to do here is find out where 200 degrees is. Well, you can see 180 is over here, and then 200, that takes us up to this point here. So we want 4.5 centimeters from here to here. So with our ruler, if we measure on 4.5 centimeters, here is 4.5 centimeters. So when we come to mark the position, here is the position. We've got lighthouse L. And that's how we go about these sorts of questions. Question number 10. A man running at a constant speed of 5 meters per second takes 66 seconds to complete a particular distance. A horse completes the same distance running at a constant speed of 15 meters per second. We have to find the difference in seconds in the times taken by the man and the horse to run this distance. First of all, we have something in this question involving speed, distances, and times. We know already speed is equal to the distance divided by the time. Now, if we take a look at the information given, for the man, he's running at a constant speed of 5 meters per second, and it takes him 66 seconds to complete a particular distance. And we know the horse also runs the same distance. So what we can do is find out from the man the distance. So the distance is equal to the speed, which is 5 meters per second, multiplied by 66 seconds. So the distance here is 5 times by 66. Well, here we'd have 30 plus 300, so that'll be 330 meters. And therefore for the horse, we can find the time. So the time for the horse, that's equal to the distance 330 divided by the speed, which is 15. 330 divided by 15, you'd find that to equal 22 seconds. And therefore, for the difference, what we'd have here is the difference equaling 66 for the man, take away 22 for the horse. 66 take away 22, that's 44, and therefore we'd have 44 seconds. Question number 11 for part A. Alice buys a pitcher for £180 and later sells it for £216. We have to find the percentage profit she's made? Well, for the percentage profit, that's equal to the change over the original times by 100. So what we have here then is 216 take away 180, and we're dividing this by the original 180 and then multiplying by 100. Well, what you'd find over here is 216 take away the 180, that's 36. So we've got 36 over 180 times by 100, and 36 divided by 180, that's a fifth. So we have 1/5 times 100, of course here would end up with 20%. And then for part B, Rashid wants to increase £345 by 17% in one step by using a decimal multiplier. We have to write the decimal multiplier to complete Rashid's calculation. Well, if we're increasing by 17%, the multiplier here will be 1.17, with the 1.00 representing 100%. If we have a 17% increase, then that would correspond to the 117%, which is the same as, in decimal form, 1.17. Question number 12. In an exam, Adam scored the following marks. So for paper 1, he scored 17 out of 20, and paper 2, he scored 19 out of 25. We have to show that he scored a higher percentage in paper 1 than paper 2. Well, if we consider paper 1, we scored here 17 out of 20. And remember, percentage means out of 100. So we want to find out what 17 over 20 is, equivalent to something out of 100. Well, here we times by 5, so therefore 17 times by 5, that's 85. So therefore 17 out of 20, that's the same as 85 out of 100, which you can see is the same as 85%. So that's what you got in paper 1. Now with paper 2, he scored 19 out of 25, and remember percentage means out of 100, so therefore 25 times by 4 gives us 100, and therefore 19 times 4, that gives 76. So in paper 2 he scored 76 out of 100, which is 76%. And what we can conclude is he scored higher in paper 1 than paper 2. So he scored higher in paper 1 than paper 2. Now for part B, the two marks are added together. We have to work out Adam's overall percentage for the two papers. Well, what we'd have to do over here is recognise that his paper will be out of 20 plus 25, and what we have here is 17 plus 19 out of this. So this calculation tells us his overall percentage. Well, over here, 17 plus 19, that's 36. So we've got 36 over 45 times 100. Now 36 divided by 45, that's 4/5. So we have 4/5 times by 100. Well, 1/5 is 20, timesing that by 4 we get 80. So therefore, his overall percentage profit over the two papers is 80%. Question number 13. For the first part of part A, we have to sketch the graph of y equals 2. Well, y equals 2, that will be a horizontal line, and it will look something like this. We have the line here, y equals 2. Next, we have to sketch the graph of y equals x plus 1. Well, it's got a gradient of 1 and it crosses the y-axis at 1. You can see when x is 0, y is 1, so therefore the y-intercept is 1. And when y is 0, we'd have 0 equals x plus 1, so x equals negative 1. And therefore here, we'd have a straight line with a constant gradient of 1, crossing the x-axis at negative 1, the y-axis at 1. Here you can see we've got the graph of y equals x plus 1, crosses here at the point minus 1, and crosses here at the point 1. And now for the third part, Sari says that the graphs of y equals 2 and y equals x plus 1 cross at the point 2, 3. We have to explain the error in her answer. Well, for the graph y equals 2, it should cross 2. So, the y value where they cross has to be 2. And now for part B, Oliver has sketched the graph of y equals x squared, that's what we see here, and we have to make 2 criticisms about the accuracy of his sketch. Well, first thing, if we've got y equals x squared, you can see when x is 0, y will equal 0 squared, which is 0. So the first point we should make is it should go through the origin 0, 0. And the second point, well, we've got here straight lines, and what it should be is a curve. So it should be a curve. Question number 14. For part A, we have to write each of the following ratios in its simplest form. Well, here we've got 8 to 10, and we need to simplify this. Well, over here we can divide both sides by 2, and if we do that, we'd have 4 to 5. We can't simplify this any further, so we have 4 to 5. And now for the second part, 300 millilitres to 2.1 litres. Well, over here you need to recognise we've got different units. So, to go from litres to millilitres, we would have to multiply by 1000, and millilitres to litres, we'd have to divide by 1000. So, we can rewrite this as 300 millilitres to, well, 2.1 times by 1000, that's 2100. So this is equivalent to 300 millilitres to 2100 millilitres. And now what we can do is divide each side by 300, and therefore 2100 divided by 300, that's 7, and therefore our ratio simplifies to 1 to 7. And then for part B, the ratio sin 30 to tan 45 can be written in the form 1 to n. We have to find the value of n. Well, sin 30, that's equal to 1/2. And tan 45, that's equal to 1. And we have to write this ratio in the form 1 to n. Well, what we can do here is multiply both sides by 2. You will find 1/2 times by 2, that's 1. 1 times by 2 is 2, and therefore we've got this ratio equaling 1 to 2, and therefore you can see n is equal to 2. Question number 15. Angie is planning a presentation evening. She writes down her costs and income. So for the costs, we've got 10 staff, each working 6 hours at £8 per hour. Food, we've got 60 meals at £8.95 each, and prizes, we've got 12 prizes at £19.99 each, and the income, 60 gets each paying £5, and sponsorship, we've got £1,000. Angie thinks she will make a small profit. Use estimation to decide if Angie is correct. Show all of your working. Well, over here, in terms of the costs, well, there's 10 staff members, They're each working 6 hours and they're getting paid £8 per hour. So this is for the staff. And then we have 60 meals at £8.95. Now this £8.95 we can round to approximately £9. So we add on 60 multiplied by 9. Remember, we're using approximations here. And then this 19.99 we can round to 20. So we have 12 prizes at £20. So now we need to work all of this out. So let's just confirm. Here we've got the food, and here we've got the prizes. So if we work this out, we have 480 plus 540 plus 240. So therefore the costs will equal a total of here we've got 40 plus 40, which is 80, plus another 80, that's 160, and then adding 400, that's 560, and then we've got 1060, and then adding another 200 here would have 1260 for the total costs. And for the income, we have 60 guests paying £5 each, so we've got 60 times by 5 plus the sponsorship. So here, this is for the amount the guests are paying, and here we've got the sponsorship. So if we work this out, we've got 300 plus 1,000, which is 1,300. And therefore, what you can see here is the small profit, that's equal to 1,300, take away the 1,260, which is equal to 40. So therefore, what you can see then is, indeed, she is correct. Question number 16. Martina has answered some questions on algebra. In each question she has made an error. We have to describe her error and give the correct answer to each problem. Well, here, for the first question, she was asked to simplify 2a times a times a. Her answer was 4a. We have to identify her error and give the correct answer. Well, over here, what she did was she added the terms. And you can see that 2a plus a is 4a, which we weren't supposed to do with timesing. And therefore, the correct answer here is, well, we've got the 2, and then we've got a times a, which is just a cubed. So that's the correct answer. And then we have to simplify x to the 10 divided by x squared. She got x to the 5. Well, what she did was she divided the powers. She wasn't supposed to do that. Instead, she should have subtracted the powers, and if we do that, we've got here x to the power of 10 take away 2, which is x to the 7, rather x to the 8. So here we should have x to the 8. And then for the third one, we've got s equals ut plus a half at squared. When s was, we have to find s when u is 0, t is 5 and a is 6. So did she sub everything in correctly? Yes, she did. And, well, 0 times by 5, that's definitely 0. And then here we've got a half times by 6 times by 5 squared. Well, this should be 3 times 5 squared. And here we don't have, it's not 15 squared. What she did was she worked out half times by 6 times by 5 all squared, which is 15 squared. She shouldn't have done that. So what this should be is, if we work from here, what we should have is a half times by 6 times by 5 times by 5. So here we'd have 3 times by 25, which is 75. So the correct answer is 75. Question number 17. The diagram shows the scale drawing of a garden A, B, C, D, and we're given that 1 centimeter represents 5 meters. So that's what we see here. And a tree is to be planted in the garden so that it is at least 10 meters from AB, closer to CD than CB, and at least 15 meters from D. And using a ruler and compass only, we have to construct and shade the region in which the tree can be planted. Well, let's take this one step at a time. First of all, let's convert everything into the appropriate scale in centimeters. We know that we've got 1 centimeter represents 5 meters, so this 10 meters would represent 2 centimeters, and this 15 will represent 15 divided by 5, which is 3 centimeters. Now, what we need to do is draw a line which is parallel to AB with the distance from this line to AB being 2 centimeters. So here, if we mark on 2 points and then draw a straight line, so drawing a straight line through these, as we see here, what we know already is it's at least 10 meters from AB, so it's everything above here. We'll do the shading afterwards. It's closer to CD than CB. Well, CB, that's this, and CD, that's this. Now, what we need to do is draw a perpendicular bisector angle for this. So if we pick any two, well, the pointy bit on your compass goes on the point C, and then if we draw a arc like so, you can see we've got 2 points of intersection with this line and this line. And then what we will do is draw an arc like this, and then retaining the same length, draw another one like this. And then if we join these up with a straight line, like so, and make sure it goes through here and here, we've got the perpendicular bisector, like so. Okay, what do we know? Well, it needs to be closer to CD than CB, so it needs to be everything above. And then it's at least 15 meters from D, and remember 15 meters is given by 3 centimeters. So what we will do with our ruler and compass is measure 3 centimeters. So 3 centimeters, that is around here. And then all we do is from the point D, draw an arc like so. So if we draw an arc with the appropriate measurements, like so, well, it needs to be at least 15 meters from D. So when we come to shade the region, here we've got the appropriate shaded region. Question number 18, we have to solve by factorising x squared plus 9x plus 20 equals 0. Well, what we're after here are two numbers which multiply to give 20 and which add to give 9. What you'd find is those two numbers are 4 and 5. And therefore, when we come to factorise, we would have x squared. When we come to factorise, we'd have x plus 4 lots of x plus 5 equals 0. So, x plus 4 is either equal to 0 or x plus 5 is equal to 0. From which you can see x is either equal to minus 4 or x is equal to minus 5. So we've got x equals minus 4 or x equals minus 5. Question number 19. On a plane, 2/5 of the passengers were British, 30% of the British passengers were men. There were 36 British men on the plane. We have to find the total number of passengers on the plane. Well, over here, we will let the total number of people on the plane equal x. Now, we know that 2/5 of the passengers on the plane are British. So, we've got 2/5 of x as the number of British passengers. Okay? So, we've got 2x over 5. We have 2x over 5 who are British. And then we've got 30% of the British who are men. So we'd have 30% of 2x over 5 being the number of men. And this, of course, is equal to 36. Now 30%, that's the same as 3 over 10. So we've got 3 over 10 times by 2x over 5 equals 36. So now if we attempt to tidy all of this up, well, 3 times by 2, that's 6. So we've got 6x over 50 equals 36. So, dividing top and bottom by 2, we have 3x over 25 equals 36. And if we divide through by 3, you'd find we have x over 25 equals 12. And therefore, to find out what x is, we have to do 12 times by 25, which is 300. And therefore, there's 300 passengers on the train. Question number 20. A bag contains 100 pencils that are either red or green. We have to describe a method you could use to estimate the number of red pencils in the bag without looking into the bag or having more than one of the pencils out of the bag at any one time. The first thing we can do is select a pencil from the bag and record the result. The next thing, we put the pencil back into the bag. We would then repeat the trial at least 10 times. We will then find the relative frequency, which is equal to the, in this case, number of red over the number of trials. And therefore, the estimate is equal to the relative frequency. Let's just write this down in full. We have the relative frequency multiplied by 100. So this is how we could find an estimate. Question number 21. The diagram shows a kite ABCD and AFE and CEF are equilateral triangles. So we've got this triangle and this triangle being equilateral triangles. And if that's the case, that means these two triangles will be equal, because if they're equilateral triangles, this length equals this length equals this length, and if this is also an equilateral triangle, this length equals this length equals this length. And whilst we're at it, we might as well add in a couple of angles. Because we've got an equilateral triangle, we've got 60 degrees in the places as we see over here. So then for part A, we have to write down the mathematical name for the quadrilateral AFCE. So we've got AFCE. Well, this over here will be a rhombus. And then for part B of the question, the ratio of the angle DAE, so DAE, which is this angle here, is equal to, well, the ratio of DAE and EAF, so EAF, that's equal to 1 to 4. And we have to work out the size of angle X, and we have to write on the diagram the values of any other angles you are using in your working. Well, first of all, if this angle is 60 and we've got this ratio 1 to 4, dividing 60 by 4 we get 15. So this angle over here is 15 degrees. Okay, so how does this help us? Well, we want to find out what X is. And we know that angles in a straight line add up to 180, so 60 plus 60 plus 60 gives us 180. So this angle here is also 60 degrees. And recognizing that angles in a triangle add up to 180, what we'd have then is X equaling 180, because we've got the sum of the angles in a triangle, take away the 60, take away the 15. So we take away the 60 and then take away the 15. This tells us what X is, which is 105. So we've got X equals 105. Question number 22. In a group of 100 students, 59 study history, 62 study geography, and 20 do not study either subject, and we have to complete the Venn diagram. So we've got 100 people in total, 59 study history and 62 study geography, and 20 study neither. Well, over here, the total for H will equal, if we do this in a different colour, the total for H is equal to 59, and the total for G, again we'll do this in a different colour, this is equal to 62. And if we call this intersection point X, then here what we'd have is 59 take away X, and what we'd have here is 62 take away X. And we need to find out the missing values over here. So both of these will add up to 100, because, well, everything inside the Venn diagram adds up to 100. So we've got the 59 minus X, and we also have the X, and we also have the 62 take X, and we also have this 20, and in total we've got 100. We have 100 people in total. And what we need to do is find out what X is. Well, 59 plus 62 plus 20, you'd find that to equal 141. So we've got 141 take away X equals 100, and therefore you'd find X to equal 41. So we've got 41 here, and then 59 take away 41, that's 18, so we've got 18 here, and then 62 take away 41, that's 21. So here is our completed Venn diagram. And now for part B, one of the 100 students is selected at random. We have to find the probability that this student studies exactly one of the two subjects. Well, exactly one of the two subjects would have the 18 from here, and would also have the 21 from here. And of course we've got 100 students in total, so this is our probability. And simplifying this, would have 39 over 100 as our probability. So we've got 39 out of 100. Question number 23. We have a straight line with gradient 4, which passes through the point 1,5, and we have to find an equation of the line in the form y equals mx plus c. Well, if we consider y equals mx plus c, m here is the gradient, which we know to be 4, and this c will represent the y-intercept. So, using this point here of 1,5, we've got 5 for the y-coordinate equals m, which is 4. Again, this 4 will represent the gradient, times by the x-coordinate, which is 1. So this 1 comes from here, and this 5 comes from here, plus some constant c. So we've got 5 equals 4 plus c, and therefore c equals 1. And knowing that c equals 1, you can conclude that y equals 4x plus 1. So we've got y equals 4x plus 1 as the equation of our line.